Hello everyone, welcome to Bizotic. Today in this video we will be learning about an interesting reasoning topic which is calendars. Calendar is a very basic thing when it comes to organization and all such stuffs, but there are a lot of interesting facts and mind-blowing things that you will be learning about calendars in this concept video. So let's begin. What is this calendar? It's an instrument which is used to keep, indicate and organize the days in a year. So that is the purpose why we use calendar. And let's see, where did it start? We follow the Gregorian calendar, which is also called as Christian calendar or Western calendar. And just to give you some thoughts about these things, Gregorian calendar, it was named after a Pope, Gregorian 13, and this was introduced in October 1582. So this is the normal calendar we follow, which starts from 1st of January and ends on 31st December. So this is the basic history about calendars. And now let's move on to the next concept, the concept of leap year. You all know this. A year with an extra day gives you a leap year. So how to find out when it comes to application level? So let's see that. A year cannot be a leap year if it's not divisible by 4 or 400. How? So the reason is every 100th year starting from 1st AD is a non-leap year, but every 4th century year is a leap year. So just to give you an example, it's 1700, 1800. These are all called as century years, are not leap years because they are not divisible by 400. But in case of 1600, 2000, 2400 are divisible by 400 and hence called as leap years. And this follows exactly the divisibility rule of 4. If you cancel these two zeros, then it's very easy. 16 will go in 4. So it's a leap year. So you can do that for the year which is the current year. So if you take 2020, so now 2000 will definitely go and then 20 will go in 4 again. So it's a leap year. Matlab that also mean it will have a extra day which is February 29. So let's go ahead and see more about it. Odd days. The concept of odd days speak about the calendars, and it's very important when it comes to defining problems. In an ordinary year, there are 365 days. Yeah, I know that there are 365 and 1 by 4 days, but on a whole, we consider it as 365 days, which means 52 weeks into 7 days plus 1. So 52 weeks plus 1 day. That 1 day is called as an odd day in every year. So a ordinary year will have 1 odd day and a leap year will have 2 odd days. So that's the concept of odd days. And next, moving forward, in a century that is 100 years, there will be 24 leap years and 76 non-leap years. This means that there will be 24 into 2. So 24 leap years in the sense every leap year will have 2 odd days plus 76 non-leap year means so every non-leap year will have 1 extra day which gives us 124 odd days. And now we know a pair of 7 days will make a week. 7 days will make a week. So giving us 124 by 7 we get 5. So in century, so in a century like in 100 years we will have 5 number of odd days in a century. And with this we will have 5 odd days in 100 years and 5 twos are 10 in 200 years. And if you subtract 7 because that makes a week, you will have just 3 odd days. And 15 for this, if you subtract 14, 1 odd day. But for 400 it will be 0 because I told you in the very beginning it is a leap century. So 1 year will be added which gives us 0 odd days. So 5 4s are 20 plus 1. So 21 will be divided by 7. So 400 years will have 0 leap years. So these, with them we will be defining the odd days examples. So anyways, so this will be available in the next slide as well. Now let's see the next bit of concepts which are the very important points about calendars. The years which are divisible by 400 have 0 odd days, as clear as explained in the last slide. So 400, 800, 1200, all of them will make 0 odd days. Last day of a century cannot be Tuesday, Thursday or Saturday because it will have 0 odd days. April and July for all years and January and October for non-leap years have the same calendar. So there is nothing much to worry about it, but still it's better you know. The calendars of two different years are same if they satisfy the following condition. So this is true. A year can have same calendar, like 2007 might be same as 2017 or 2027. So that depends on these factors. What are those factors? The years must be the same type, that is both must be either ordinary years or leap years. January 21 of both the years must be same day of the week. If that is working, and then the calendar will be same. Now this is a table of odd which explains the relationship between year and number of odd days. So ordinary year 1 odd day, leap year 2 odd days, 105, 203 and 301, 400, 0. So whatever that I had explained before, I have just put it on a table. And next one more table, the table of odd, which explains the relationship of odd days. So this is the most important one which will help you to solve problems on calendars. Sunday constitutes value 0, Monday 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5 and Saturday 6. If the value is 7, so then it will be 0. So which is Sunday again. So these are all the main key concepts that you should be learning when it comes to calendars. So with these concepts, we will be solving a lot of problems in different ways in our next video. Thank you so much for watching.